All right, so here is an example where it might be useful to combine, or I'm sorry, to be able to write this expression in non-fractional form. And again, this is the kind of similar idea that a lot of times it's just not beneficial to have something complicated in the denominator. We've seen this before with radicals and the like. So we're actually going to use, or speaking of radicals, we're actually going to use a method very similar to how we got rid of complex conjugates. And in this case, what we're going to do is we realize that if we multiply this by its conjugate, okay, then we'll actually be able to eliminate one of these pieces here. So what we're going to do is the conjugate of 1 plus sine x is, okay, and you can think of difference of squares in this case, 1 minus sine. And of course, if we do it to the bottom, we're going to need to do it to the top as well. Okay. And if we multiply these out, okay, what we're going to end up with is we realize is we get 1, on the top we'll just get 1 minus sine x. Okay. And then on the bottom, we're going to get basically it's the reverse of difference of squares, so it'll just be the first term here, 1 times 1 squared, okay, 1 squared obviously is still going to just be 1, okay, minus, and then the middle terms will cancel out if we actually FOIL this, and you can go ahead and do that yourself if you choose, minus sine squared on the bottom here. Well, now if I go to my identities, I can realize that this is a form of the Pythagorean identity cosine squared plus sine squared equals 1. If we subtracted the sine squared from both sides, then we would just get cosine squared is equal to 1 minus sine squared. So as we can see here, in fact, cosine squared is equal to what we have here, so I can replace it, and then I get 1 minus sine x over cosine squared. Now there's another method here that we're going to use. So this actually has two methods. So one method that you'll want to add to your method sheet is if you have a denominator, okay, where it's something like 1 plus sine x, and it can be other examples of this. Again, this is a strategy, not a rule. You can multiply it by its complex conjugate, and you might end up getting and you should be able to end up getting something that can simplify from a binomial down to a monomial. Now, in this case, what we're going to do is we're actually going to split up this fraction. Okay? I can see here that I have like this sine x over cosine x, and I might be able to simplify it a little bit further. Actually, now that I look ahead, I don't think it's going to get too much more simple, but if we want to just look at another strategy of how we can kind of simplify these a little bit further, this will actually simplify out a little bit. So what we end up getting is, well, I can rewrite this as 1 over cosine squared minus sine over cosine squared. And if you're not sure on that, just work backward. These have a common denominator, which means we could combine them together, and we would just subtract the numerators, 1 minus sine x, and the denominator would remain the same. And that's another strategy you'll want to add, is when you have a binomial on the top and a monomial on the bottom, it might be beneficial to break that up into two pieces. Now, this piece right here, well, I can go ahead and just write that. I'm going to section off this piece right here. I can go ahead and just rewrite this part right here as secant squared. Okay? And then this piece, we're going to use a strategy that we used yesterday. And I can see here that I have sine over cosine, but I have an extra cosine. So what I'm going to do is I'm going to break this into a product of sine x over cosine x times, and I'll give you a second to see if you can figure out what the next fraction is going to be, but it should multiply times this to get back to our original expression there. Yeah, you should have gotten that, well, we want the denominator to multiply times something that'll give us cosine squared. And then the numerator, well, it's already sine x, so I just want to put a 1 there. because 1 times sine x will get me back to where we started. And basically the idea is that these two pieces right here, you multiply and you get back to there. But now I know that this piece is in fact just tangent. And then I have secant squared minus tangent, okay, times, well, that's just secant. Right there. Okay? And if we were really just feeling like doing some extra work, obviously this has the greatest common factor of secant. There's no real point in factoring it at this point since they simply said to kind of simplify it. So in this case we would in fact be done.